There are four common elements to computational thinking. 1. Problem decomposition, breaking down data, processes, or problems into smaller and more manageable parts. 2. Pattern recognition consists of observing and recognizing patterns or trends in data. 3. Abstractions or models allow us to identify the general rules or principles that are responsible for the patterns and trends. And 4. Algorithm design consists of developing instructions or procedures that can be used to solve this problem and others like it. Most of us have occasion to do all of these on a fairly regular basis. By formally recognizing these steps and identifying their use, we put ourselves in a better position to understand computational thinking processes. The busy landlord is a great little problem for learning about computational thinking. In this problem, a very tall apartment building has floors numbered from the ground floor, 0, on up, to a very great height. It also has a large number of basement levels, numbered -1, just below the ground floor, -2, the basement below that, and so on. The landlord for this building begins on the ground floor and has to visit the tenants on various levels to collect rent, perform minor repairs, drop off mail, etc. Visits to tenants on the floors are coded as a series of up arrows and down arrows. So an instruction to visit the first floor would be up. The instruction up, down, down would leave the landlord on the first basement at -1. Which of these instructions would result in the landlord ending up on the ground floor? The correct answer is all of these. Each one of these goes up or down and leaves the landlord on the very first floor, floor 0. The instruction up, up, down, up, leaves you on which floor? The answer is 3. Up, up takes you from floor 0 to floor 2, down takes you to 1, up takes you to 3, down takes you to 2, and up takes you back up to 3. These rules are pretty simple and easy enough to follow by hand. It would get very tedious, however, trying to figure out where you ended up after following these instructions for 100 floors. How would you explain to someone else how to solve this problem mechanically? What are you keeping track of when you go through and solve this problem? Are there other ways to solve the problem that might make it easier or more efficient? Here's how computational thinking would permit you to solve the problem. Analysis like this isn't the same every time. It can vary from person to person and from problem to problem, but it often ends up following this kind of path to a solution. Step 1. Problem decomposition. In the busy landlord problem, there are 100 instructions that I've been given, but there are really only 2 things I have to do: move up 1 floor or move down 1 floor. Number 2, pattern recognition. There aren't really any patterns in this data that I can see. The floor movements appear to be random. But as I think about how I myself would go through solving the problem, I notice that I'm always keeping track of my current floor. When I see an up instruction, I adjust my current floor up by 1, and I do the same thing when I see a down instruction. That may seem kind of obvious as a strategy, but it turns out there are other strategies that we might use. For now, I'm going to stick with this one. Number 3, abstraction or model. The busy landlord problem is ostensibly about what floor the landlord is on, but the current floor is easily modeled as just a single value. If I keep track of the current floor value and just add 1 or subtract 1 as I go through the list of instructions, I'll always know where I am. At this point, I'm not even thinking about the floor I'm on anymore. I'm just keeping track of that value. And finally, number 4, algorithm design. Our algorithm, then, the series of steps we would give to someone, whether it's a person or a computer, to solve the problem, would look like this. Identify the starting floor, get the next movement instruction, either up or down. If it's up, add 1 to our current floor count, and if it's down, subtract 1 from our floor count. Keep getting instructions until there aren't any more, and then report what floor we ended up on. The pseudocode for this, the same instructions written in a manner that's very close to something that a computer could understand, looks like this. Now here's an actual program solving the problem. Some of the lines in this program are just little notes to ourselves, what programmers call comments. The actual code that makes this work are the lines that start with instructions equal. And running this program, here's what we get. So you can see that our problem-solving approach using computational thinking has led us to a solution that is easily implemented on the computer.